So, today I will discuss how to measure the focal length of mirror, basically concave mirror and convex mirror. So, let me demonstrate the experiment, how to do the experiment, but unfortunately I will not be able to show you the image of the needle because it is getting the image in camera is we are feeling difficulties. Anyway, so what is the procedure for doing experiment? So, take a mirror, concave mirror uh, for measuring the focal length of that mirror. So, you have to so this is the holder of the mirror. So, you have to hold this mirror. Now, this mirror is, so basically we tell this is the upright. So, it's basically you see this is the this is the holder of mirror, this is one part, and this we tell this upright. Okay. So, basically here you can see there is a mark, index, we tell index mark, index line. Okay. So, this line when it coincide with the where the coincide with the some reading on the scale. So, that reading shall we note down. Okay. So, here so you can put this and you can move easily. Now, when you want to fix it, so basically here I will show you this, just press it and rotate it. Okay. So, then it will be fixed with the upright. So, press it and then you can rotate it. Okay. So, if I want to fix it at a particular position, so here I want to fix it. Okay. So, I will press it and then rotate it. Okay. So, now we cannot move, now we cannot move. So, if you want to move, just release it and it will move. Okay. So, that is what here I have fixed the mirror. It is I kept it at 0 position. Okay. So, reading of the mirror is basically 0. So, for the whole experiment I will not change the position of the mirror. Okay. For a particular this position of the mirror we will do the experiment. So, now this is the object needle, this is the object needle. Again this you see as I mentioned. So, with this basically we have put this needle where I kept it. Yes. So, this can be this one also. Okay. So, one has to put this needle. I think I cannot put this one. Anyway, this I cannot put, but this so actually this is the needle. Okay. So, this needle I put here. So, you can adjust the height, fix it. Okay. Now, put here. Okay. You can change the position, Okay. So, another let me keep it here. So, now I have mirror, and generally you take it close to this and see the look at the center, look at the I think center of the mirror, and see whether this adjust this height, it should be at the center, So, actually this way you should see, it should be at the center of the, so I can see image, but I can adjust the height also. Okay. So, I can adjust height, fine. Okay. I can adjust height. Okay. So, I can see the image of this one, erect image, it is very close, erect image I can see. Now, I am changing the position of the object needle, I change the position of the object needle, then I can see, yeah, this is the erect image. Now it is changing, it's becoming diffuse the image, now it's inverted, now it is inverted. Now I can see the inverted one. Okay, so focal length is basically it's at this, around this point it will be focal length. So now I will keep the distance slightly more where I am initially I am getting the inverted image, inverted clear image when I am getting. Yes, I think I have to reduce slightly height, so it looks, because now inverted it has gone down. Yes, needle tip I am putting at the middle of the mirror. Okay, yes, so yes, clear image I can see. When I am rotating, moving further and further, I can see the image uh, of the tip of the needle. Okay, yeah, further this. So it's the, so approximately this focal length of this mirror you can see. So I found that it's around 16, because it's the invert, it's just erect to inverted, it's just when it's erect to inverted. So when reading is around yes, around 20 also. Okay, so it's approximately this focal length of this mirror will be around 20. So plus minus some, this is just the approximate. So I have to keep the distance, I have to keep the distance of the object will keep between f and 2f, means between f focal point and the at the point of center of curvature. Okay, 2f c. Okay, so if it is 20, so this will be around 40. So say let me keep it at say 25. Okay, I will keep it at 25. Now keeping at 25, I will fix it. Okay, so that there should not be change of this position of the object. Okay, now look at the image of this inverted image through the mirror. Fine, I can see, but unfortunately I cannot show you. Yes, I can see. Now what is the task? So I will take image needle, okay, and put here. So image, where you will get image? So when this object is at f focal point, image you will get at infinity. Okay, when this object is at 2f, means at the center of curvature, 2f distance, so you will get the image at the same point. Okay, so now when, that means when you are increasing the distance of the object from the focal point, okay, towards the center of curvature when you are moving. So image from infinity to, it is coming to the center of curvature. That means from focal length you are increasing the distance of the object and going towards the center of curvature. So image will form uh, beyond the center of curvature. Okay, it will form between infinity to curvature. Okay. So, I can guess that where I can get the image approximately anyway. So, now this also you have to make this of same height, it is the more or less same height. Yes. So, here what you will see, this image of that one also you will see, but you do not concentrate on the image of this one, okay. You concentrate on the tip of this real this image needle, and look at the tip, inverted tip of the object, okay, object needle. So, now this object needle, object image of the object needle and the real this tip of this image needle, okay. So, they will so you have to concentrate the tip of these two, one is image needle tip and another one is image tip. Okay. So, now procedure is you have to change the position. So, you have to first I will take it out, and first I will concentrate at the, I will look at the tip position, I think yes, inverted tip position of the object, okay, tip position of the image. I can now I set my eye in such a way, so it is at the middle of the mirror. Now, keeping my eye at this place, I will put the this image needle. Now, I will set my eye in such a way, so this tip of the this needle, image needle, and the tip of the image, they are on the same line. Okay. Now what I have to do is the parallax method. Okay. So, I will close my left eye and open my right eye, and I move my head left and right, and I have to see that this both teeth at which, for which position of the needle, object needle, this image needle. So, they are moving together, they are not detached, but at the moment they are detached. Now, I am putting here, okay, it is coincide, but they are detached. So, I have to find a position where they will not detach. Okay. So, they will move together. No, they are no, I have to go away. It is expected because my object position near the focal length. So, image will be far away from the center of curvature. If I move more, no, yeah, sometimes you have to this, okay, yes. So, do not see the image of this one. Okay. So, you have to concentrate your this point and the image of this one. Okay. I can see they are moving together, almost they are moving together. Okay. So, one has to find out, but they are slightly we have to adjust the mirror, angle of the mirror slightly, but I will not disturb. at some is okay. So yes, so I have to change. I have to change and find out the uh, yes, no, yes, mm, no, no, they are detached. No, yes, they are moving. I am close to that. Okay, I am close to that. No, sir, I think I have to either. Yes, it's. Yes. So it's more or less I found the position. Okay. So this the image needle and the image tip is coincide at this point. So this is the image distance. Okay. So you have to note down. You have to note down the you see uh, observation number 1. What is the mirror position? So P it's the 0 reading. Here what is the position of this this object needle? So this 25, okay, 25, and then uh, by parallax method we found the position of the image needle, and its reading is I can see 54.2. It's the 54.2. Okay. Okay. So what you should do? Uh, you should take uh, so this generally what we suggest, you take this reading uh, 3 times. You take this reading 3 times, again you adjust and take the reading. Okay, fixing the keeping fixed that one. Okay. So then whatever you will get, whatever you will get, so you can take average of that. In table I have not put, but you can take average of that one, or for each one you can find out the uh, uh, U and V. Okay. So so I think you take the average of this one. Okay, and then your PO will be, so difference between this. So here I think direct reading will be the PO, note down. Okay, here whatever the average you will get for these 3 reading you note down, and V will be basically not 54, it will be 25, it will be 25. Okay, so that is fixed. Now for image position you are adjusting. Okay, taking 3 reading and take the average of that one. So that this minus 0, that will be the it is not necessary to keep it at 0, but if you keep at 0, so is the advantage. It can be other reading also. Okay, so these are the calculation. Okay, so this is the first observation for a particular mirror uh, for a particular object distance. Now I will go for second observation. Okay, for each observation, for second observation in the sense for second distance, say I will keep this one, say 20, say this is a 25, then you can change by 20, 27.5, okay, and again find out the image position, okay, and take this three times this reading, take the average of that one. So similarly, observation 3 you take for the, say 30, okay, better write 25.0, 30.0. So change the position of the object by 2.5 centimeter, and for each position you find out the position of the image needle, okay. How to find out that I explained you. So for uh, each u object distance, you have to find out the image distance following the method as I described. So you will get basically data for different u, you will get data for different v, okay. So then you can calculate f, and you can take the average of the f, for that will be the focal length of this. So this way one can find out. Another way, you can use graphical method to find out the focal length. So that I will describe. So two ways you can plot graph. So one is UV graph, okay. UV graph, in x axis you can plot u, and y axis you can plot v, okay. So from UV graph you can find out the f. How to find out I will tell you. Also you can plot 1 by u versus 1 by v graph, okay. From there also you can find out the f, okay. So basically, after taking data u versus v, you can calculate 1 by u versus 1 by v, okay. So draw u versus v curve, okay. So here, since in case of concave mirror, u value and v value both are negative, so that is why this is the x axis. So we have plotted in the negative value direction, okay, okay, and this also v negative. So y axis, this is the y axis, this is the x axis. So the negative x, negative y. So now choose the scale and plot your data u for different u, what is the v value, okay. Now it will be basically curve like this, okay. Now here how to find out the focal length from this curve. So you have to consider the fact that the point on this curve, if you get a point on the curve where u and v value are same, okay. So when u equal to v, it is only possible when image and the object both are at the center of curvature, okay, at C, okay. So from the center, if you draw a line at 45 degree, okay, at 45 degree, okay, where it will meet here, okay. So for this, this point will be basically this point will be basically the point where u and v value will be equal. And this value, center of curvature, what is the distance from the mirror? So that is basically 2f. Okay. So here whatever, so from this graph itself, drawing this line at 45 degree, you can find out this point. Now what is the u value and what is the v value, we can find out. Okay. So that equal to 2f. So f equal to, you can either u by 2 or v by 2. Okay. You can calculate the f from this curve. Another way, this you can plot 1 by u versus 1 by v. Again these are negative, so negative axis we have chosen, negative axis we have chosen. Okay. So if you plot 1 by u versus 1 by v, so basically you will get a straight line. Okay. So 1 by v equal to 1 by u plus 1 by f minus 1 by, because 1 by, you know this 1 by f equal to 1 by v plus 1 by u. Okay. So 1 by v equal to 1 by f minus 1 by u. So minus 1 by u. So it is the just y equal to mx plus c, right. So m is basically 1 minus 1, negative slope. This curve you will get, straight line you will get is a negative slope, right. And c is the intersection of this line on the y axis, right. So intersection is basically OB, right. This is the intersection point, so OB is the intersection. Okay. So plotting this 1 by u versus 1 by v curve, you can find out the intersection of this line, on the y axis. So that is basically, so there then you can find this length of this OB. Okay, from this, because these are some scales are there. So for drawing graph, you know. Okay, so what is the value of b or this OB? So you can find out. So this is the c value. C value, c is nothing but this 1 by f. So OB equal to 1 by f. OB from the graph you will find out. So f equal to 1 by OB. Okay. So this way we can find out the focal length of the concave mirror. Okay. So I think I describe in details, okay, how to do the experiment and how to find out the image distance. Okay. So in next class I will discuss about how to find out the focal length of the convex mirror. Also how to find out the focal length of the lenses, convex lens, concave lens. Okay. So procedures are more or less similar. Okay. So I will demonstrate in next class. So I will stop here. Thank you for your attention.